Question 1. Which instrument is the most suitable for measuring the thickness of a single sheet of paper? We have to check the smallest value which these instruments can record. A 15 centimeter ruler can record 0.1 centimeter, the smallest. The balance cannot be used. It is used to measure the mass, not the thickness. A meter rule or a meter scale, the least count is 0.1 centimeter. And the micrometer screw gauge, that is 0.01 millimeter. So the most accurate apparatus here, which can be used to measure the thickness of a single sheet of paper, that is micrometer, because single sheet of paper will be very thin. So micrometer can record a very small value. That's why it is the most accurate. In question 2, the diagram shows the distance and time graph for 4 objects, which graph represent an object moving at an increasing speed. So remember, for a distance time graph, if we have a distance and time graph, what the gradient or the slope represent the speed. So because the increasing speed is there, if the speed is increasing, it means the slope should also increase. So here it is a horizontal line, so it means slope is 0. So speed is 0. For B, it is a straight line with a constant slope. So it means the slope is constant, so speed is constant. And for C, the slope or a gradient is decreasing. So it means the speed is decreasing. And option D, the angle with the x-axis, the slope is increasing. So it means the speed is increasing. So D is the right answer for this. In question 3, an object which is having a weight of 6.4 Newton on Earth, where the gravitational field strength is 10. Which row state the mass and the weight on the moon, where the gravitational field strength is 1.6? So first we'll find the mass on the Earth, and mass of an object does not change. So we have the formula weight equals mass into gravity. So weight on the Earth is 6.4 Newtons. The mass on Earth we don't know, and the gravitational field strength of our gravity is 10. So it will be 6.4 divided by 10. So mass on the Earth is 0.64 kilogram. And if mass on the Earth is 0.64 kilogram, what will be the mass on the moon? The mass does not change. So the moon, it will also have the same mass, because mass is the amount of matter or number of the particle, like how many particles are there, the total number of the particle. So mass of an object does not change. As the mass of an object does not change, now what will be the weight on the moon? So weight is mass into gravity. Mass is equals to 0.64, and the gravitational field strength of the moon, that is 1.6. So 0.64. So it should be 0.64 multiplied by 1.6, that is equals to 1.02. So for question 3, A should be the right answer. Question 4, which substance in the table has the lowest density? How to identify the density? Density is mass present in a unit volume. So mass of an object divided by its volume will get the density. So 1.2 divided by 1, so that is 1.2. 1.5 divided by 1, so that is 1.5. 1.8 divided by 2, so that is 0.9. And 2 divided by 2, so that is 1. So which is having the lowest density? That is the olive oil. So C is the right answer. In question 5, a 20-meter long bridge is there, as you can see on the figure, and it is supported, the unit and the weight of this bridge is 100 kilonewton or 100,000 Newton. And there are 2 pillars are there, each is applying a force T1 and T2. The two pillars exerted a force T1 and T2 at the end of a bridge. What are the values of T1 and T2 when the van, which is 24 kilonewton or 24,000 Newton, is on the bridge, which is 5 meter from the left-hand pillar. So this distance is 5 meter. Whenever you see object fixed from one end, so we will always use the concept of a moment or a turning effect. And now there are two pillars, so it's up to you. Any one of them you can consider as the pivot. Example, I consider the first pillar on the left-hand side as a pivot. So two things are there. According to condition of equilibrium, there is no resultant force, or we can say the upward force equal to downward force. So what is the upward force here? The upward force is T1, T2, and the downward force is 24 and 100. That is one of the condition of equilibrium. The second thing, when object is in equilibrium or balance, there is no there is no turning effect, or we can say the clockwise moment equal to anti-clockwise. So if we consider the left-hand pillar to be a pivot, a point of rotation, so this 24 kilonewton will cause a clockwise rotation. This 100 kilonewton will also cause a clockwise rotation, and this T2 will try to cause an anti-clockwise rotation. But because it is equilibrium, so we can say the total clockwise moment equal to total anti-clockwise moment. When an object is in equilibrium, the clockwise and anti-clockwise moments are equal. So this is 24 kilonewton. Because all the options are in kilonewton, so I don't have to convert the unit. So I can simply write 24 multiplied by distance from the pivot, that is 5, plus the force 100 kilonewton multiplied by distance from the pivot. So what is the distance? Because the weight is, it's a uniform bridge. So whenever it is uniform, it means it is acting, weight is acting at the center. So if it is 20-meter long bridge, then the distance, this will be 10 meter. So it will be 100 into 10. So this is the total clockwise moment. So 24 into 5 plus 100 into 10, that's a clockwise, and total anti-clockwise, that is T2 multiplied by distance from the pivot. So that distance is 20 meter from the pivot. So into 20. Then we simplify 24 into 5, that is 120. So this is 120, and 100 multiplied by 10, that is 1000. And this 20 is multiplied, other side will be divided. So it will be 1000 plus 120, and that is divided by 20. So what is the value of a T2 when we calculate? So it will come out as 56 kilonewton. So which option? The value of a T2 is 56 kilonewton. So that is option C. And I can find the value of T1 as well to confirm that answer is correct. So how I can get the value for T1? We'll use the first condition for object to be in equilibrium. If object is in equilibrium, the total upward forces must be equal to total downward force. So the upward force is T1 and T2. So I can say T1 plus T2. And the downward force is how much? 24 kilonewton, or 24 and 100. So the downward force is 124. The upward force T1 plus T2 we already calculated, which is 56. So 56 is added, other side it will be subtracted. So 124 minus 56, so this will give us 68. So T1 will be 68 and T2 will be 56. Then in question 6, a spring which obeys Hooke's law, unstretched length is 10 centimeters. So we have a spring and the length of the spring is 10 centimeters. A load of 20 Newton is suspended. So we add a load of 20 Newton. The new length of a spring is 36. So the spring new length is 36 centimeters. We have to calculate this value of a spring constant K. So we have the formula F is equals to Kx. Force is equals to spring constant times the extension. We need the spring constant, so we need K. K is equals to F divided by X. Because we need this K, so it will be force divided by extension. How much force we applied? We applied a force of 20. How much is the extension? Original length of a spring was 10 and the new length is 36. So how much it has extended or increased? So it will be 36 minus 10, that is equals to 26. So extension is equals to 26. So this will be 20 divided by 26. And why we did not convert the centimeter into meter? Because all the options are Newton per centimeter. So it means the length should be in centimeter. If all options were in Newton per meter, then we have to convert the length into meter. So it will be 20, the force divided by the extension. So that is 0.769, which is equals to 0.77. So option B is the right answer for this. In question 7, what is the relation between the impulse acting on an object and the change in the momentum of an object? So impulse is basically change in momentum. Impulse is equals to mb minus mu. This is one formula of impulse, or impulse is force multiplied by time. These are the, so either change in momentum or force into time. So which one? As you can see, the option A, that impulse, we have to mention which is equivalent to impulse. So impulse is equivalent to change in momentum. In question 8, the electrical energy may be obtained from a nuclear fission. In which order is the energy transfer? So first, we have a nuclear energy is there, like the nuclear fuel is there, and due to nuclear react, when we carry out a nuclear reaction, that nuclear energy converted into a heat or internal energy, which convert the water into steam, and steam rotate the turbine, and turbine is connected to generator, which produce electricity. So first we'll have a nuclear fuel, then in a reactor or a boiler, because in a nuclear fuel, the nuclear fuel react inside a reactor, which produce heat energy, and that heat energy convert the water into steam in the boiler. When the steam collide or rotate the turbine, which is connected to coil of the generator, which produces electricity. So D is the right answer. In question 9, a motor of power P, a force F is on the object, exert a force F on the object. The object move a distance D and the time that force act is T. Which equation could be used to calculate the time? So first, what is power? Power is work divided by time, or energy divided by time. And what about work? Work is force into distance. So power will be equal to force into distance divided by time. But if we need time, so if we want time, time is in denominator, it will go there in numerator, and power is there in numerator, it will move to other side in denominator. So time will be equal to force multiplied by distance divided by power. So force multiplied by distance divided by power. So B will be the right answer. In question 10, a scientist uses an electric motor to lift a load through a vertical distance 2 meters. So using the electrical motor, we are lifting a load of 2 meters to a distance of 2 meters. He then increases the input power. And repeat the experiment, the efficiency of the motor does not change. Like if input power is more, it means Now, if efficiency is constant, the formula for efficiency is equals to useful power divided by input power times or multiply by 100, or input power, if I cross multiply, input power is equals to useful power multiply by 100 divided by efficiency. So what he did, he then increases the input power and repeat the experiment. Which row correctly describe the effect that this have on a useful work done and the time? Look, work done, what is the work done? Work done is a product of force and distance. If I'm lifting, like example, two objects to the same height, the one I'm taking 2 seconds, another one I'm taking 10 seconds. So work done does not depend on the route or the path or the time we take. Work done will be same to lift if the two objects are identical. If one of the object I lift in 2 seconds, another one in 10 seconds. The work done does not change. Why? Because work done depends on how much load we are lifting and how, for what distance we are. It does not depend on the time. So if we increase the input power, if we change the power, the work done does not change here. Why the work done does not change? Because work depends on what force we are applying and to what distance we move the object. Does not depends on power. How power will be affected if we increase the input power, it means the output power will also increase, and power is a product of work divided by time. So if the power is increased, what will happen? The same work will be done in a short time. So if we increase the input power, what will happen to work done? Work done will be same because we are not changing the distance, we are not changing the force, but we are doing it the work faster. So the work done remains the same because it does not depend on the time. But what happened to the time taken? Because as we increase the power, so the same amount of work can be done in a short time. That's why the power increases as the time decreases. Question 11, 4 containers are filled to the top of this with the same liquid, not same amount, same liquid. So the question is, which container has the greatest pressure? So pressure exerted by the liquid depends on density, gravity, and depth. So which one exert the highest pressure? So you just have to check the depth, the one which is deep, that will exert the highest pressure. So A will be the right answer. The pressure, as we know, the pressure exerted by the liquid depends on density, gravity, depth. We are using a same liquid, so density does not change. Gravity is constant. So means one which is having a greater depth will exert more pressure. So which one is having a greater depth? A is having a greater depth. That's why A will exert the highest pressure. In question 12, a liquid is evaporating and the liquid is evaporating and the liquid is not boiling. So we know evaporation is a cooling process. So most energetic molecule at the surface of a liquid escape. So which statement about a liquid is correct at an instant in time? Any molecule can escape from any part. That is wrong because molecules only at the surface can escape. Any molecule can escape, but only from the liquid surface. Not any molecule, it should be most energetic molecule because most energetic molecules can escape. So only molecules with the inner, because what happened in evaporation, the most energetic molecules, the molecule which have the highest amount of energy, they can only go out by breaking the intermolecular forces. So most energetic molecules at the surface of a liquid can escape, not any molecule. So C is the right answer for this. In question 13, the diagram shows two cylinders which are connected by a narrow tube fitted with a tap. One cylinder contains 80 cm cube of a gas, so this is V1, and the pressure is 2 exponent 5 Pascal. So pressure here, that is 2 into 10 to the power 5 Pascal. That is the new volume. V2 is there. The other cylinder contain a vacuum. Originally it is vacuum, but the volume of an evacuated cylinder is 20 cm cubes. The tap is open so that the gas can flow to fill both cylinders. So the gas is like here. First, what happened? This was empty. Like there is a vacuum here. So if this was a vacuum, so initial volume is V1, initial pressure is P1. But what happened? When you open the tap, so gas is present in both of them. Like gas is present in this one and some of the gas is there in the other one. So what is the final volume now? Because 80 plus 20, so the final volume will be 100. It's not like all of the gas transferred to 20 cm cube. It's like gas occupying both cylinders as we open the tap, as we open this tap. So gas particles are present in both cylinders. So what is the total or the final volume of a gas now? It is equals to 100 cm cube. So the temperature does not change. What is the new pressure? So we will always use the formula whenever for a gases, the temperature is not changing. So P1 V1 equal P2 V2. So P1 V1 equal P2 V2. So P1 is the first pressure, which is 200,000 Pascal to exponent 5. V1 is the first volume, which is 80 cm cube. P2 is a second pressure, we don't know. And V2 is a second volume, so that will be 100. So 100 is multiplied here. Other side, it will be divided. So it will be 2 exponent 5 or 200,000 multiplied by 80 divided by 100. So when we simplify this, it will come out as 1.6 into 10 to the power 5 Pascal. So B will be the right answer. Question 14. An aluminum block has a mass of 200 gram. The specific heat capacity, look, if specific heat capacity is joule per kilogram degree centigrade, so mass should be in kilogram. So if it is 200 gram, we should convert into kilogram, divide by 1000, so it is 0.2 kilogram. How much energy is needed to increase the temperature from 20 to 110? So the formula which used whenever there is a change in temperature, E equals Cm delta T. If there was a change in state, E equals M into LF, latent heat of fusion or latent heat of vaporization. That is in the case when there is a change in whenever there is a change in state, E equals M into LF or M into LV. But if there is a change in temperature, E equals Cm delta T. So specific heat, it is 900. Remember, if specific heat capacity is given in kilogram, joule per kilogram, so mass should be in kilogram. So this will be 0.2 and the temperature change is 110 minus 20 because we use the temperature change. So when we multiply these all, so it will give us 16,200 or C will be the right answer. In question 15, the diagram shows liquid in a glass thermometer. Which change in a design will make it more sensitive? What is the meaning of a sensitivity? Sensitivity means for a small change in temperature, there is a greater change in the amount of liquid. So that is called sensitivity. And how sensitivity can be affected? How we can make thermometer more sensitive? Number one, we can use a large bulb, or we can use more liquid inside, or we can use a thin capillary or thin bore. So these are the factors which will affect the sensitivity. Increasing a density of a liquid, if liquid become more dense, it means it will be less sensitive, because high density liquid cannot change their volume too much. And if density is more, its volume will be less, so it will make it less sensitive. Increasing a diameter also make it less sensitive. Increasing number of marking on the scale, that is actually affecting the range, not the sensitivity. And increasing using a large like volume of a bulb or larger bulb, it increases the sensitivity of a thermometer. Question 16. The diagram shows a pan used for cooking food. Which row correct for a material used to make the base and the handle? Handle should be insulator and base should be conductor. So for question 16, B is the right answer, because we are supplying heat energy. So the base should be made up of a material which can conduct, and handle should be made up of a material which does not conduct. Question 17, as you can see, this is a diffraction. The diagram shows a wave in a ripple tank containing water. The wave approaches a barrier and it passes through. The gap size is about the same as the wavelength. Now the gap size increases. If we increase the gap size, what will happen? It reduces the diffraction. Like if the gap, larger gap, small diffraction. So what pattern we will observe? So this is how we represent a small diffraction. So what happened? The ripples get closer. Ripple get closer means the wavelength is changed. That is wrong. The ripples are further apart. It means the wavelength increase. That is also wrong. The ripples are more curved. That is also wrong, because if diffraction is less, then it should be less curved. So D will be the right answer, because when the gap is smaller, the ripples will be more curved, more diffraction, more curved. But if the gap size is larger, then the diffraction will be smaller, so it will be less curved. In question 18, the diagram shows a wave. Which row correctly indicate the amplitude and the wavelength? Amplitude is a distance from mean position to extreme. So distance from 1 to 2 or distance from 2 to 3 is representing amplitude. And the wavelength means length of one wave. So one trough, one crest, or distance between two successive crests or two successive trough, that is representing the wavelength. So distance between 1 and 2 or 2 and 3. So 1 and 2 is, and what about the wavelength? The distance from 4 to 6. So B is the right answer, because length of one wave, like one crest and one trough, or one trough and one crest, or distance between the two successive crest, or distance between the two successive troughs, these all lengths are known as wavelengths. Question 19, two beams of a light are both of same color of red. One beam is traveling through air, the other is traveling through water. Which beam? Each beam has a different brightness. Which quantity is same for the set of the wave? Because they are same color, so if they are same color, they should all have the same frequency. Does not change. Like if wave travel from one medium to another, the quantity which remain constant, that is frequency. So frequency, remember, it never changes for a wave. The speed can change, the wavelength can change, but the frequency remain unchanged. The question 20, the diagram shows a ray of a light in air incident on a glass block, and some of the light is refracted and some of the light is reflected. The two angles P and Q are marked on the diagram. Which row give the angle of incidence and state whether and state whether the total internal reflection occur. Look, first thing, for total internal reflection to occur, light should travel from denser medium to rarer medium. Like light should move from glass to air, not air to glass. So the total internal reflection cannot occur as this light is not traveling from glass to air, it is traveling from air to glass. So there will be no total internal reflection. And which one is the angle of incidence? Angle between the normal and the incidence is called angle of incidence. So which one is the angle of incidence? Q is representing the angle of incidence. So C is the right answer. For total internal reflection to occur, what should be the figure look like? It should be the light traveling, like light should strike the denser to rarer boundary, and no component of a light should go out. All of the component will bounce back. That is called total internal reflection. But this one is a simple refraction in which the light moves from air to glass.